Good day, learners. Welcome back to our chemistry class. In today's class, we are going to continue on our Gay-Lussac's and Avogadro's laws. We are going to continue on the calculation from where we stopped at. Just before we venture into this properly, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent lessons. And don't forget to share, like, and comment. Example 1. A certain quantity of carbon was burnt in excess of oxygen. If 100 centimeter cube of carbon dioxide were formed, calculate the volume of oxygen used in the burning. All measurements being made of the same temperature and pressure. From the question, we are meant to understand that carbon is burning in oxygen to produce carbon dioxide. That is, carbon burnt in oxygen to give carbon dioxide. If you could recall, in our laws of Gay-Lussac's and Avogadro's laws, the laws are talking about gases. So in this case, carbon will be neglected. Instead, we deal with oxygen and carbon dioxide. So we are told that if 100 cm cube of carbon dioxide were formed, calculate the volume of oxygen. Now, initial volume here is going to be one volume here, and this is one volume as well. So taking it to our centimeter cube, 1 centimeter cube is producing 1 centimeter cube here. Now, 100 cm cube of carbon dioxide was produced. So this carbon dioxide, 100 cm cube of this one was produced. Then how many of these will be produced? From here, cross multiply. S times 1, we have x is equals to 100 times 1, we have 100. 100 centimeter cube of oxygen. So which means that 100 cm cube of oxygen will be produced from 100 cm cube of what? Carbon dioxide. Example 2. If 40 centimeter cube of hydrogen were explode with 50 cm cube of air, assuming air contains 80% nitrogen, 20% oxygen, calculate the composition of the resulting gases. All measurements being made at room temperature. One thing we have to note is this. Look at this. We have 40 centimeter cube of hydrogen. We are exploded with 50 cm cube of air. Volume of air is 50 cm cube. Now in air, what is the substance that is reacting in air? Actually, it is oxygen. So which means that oxygen is the only gas that is responsible for combustion in air. Now, hydrogen is now was exploded with air, meaning that we have hydrogen combining with oxygen in air to give water vapor. So you must write a balanced chemical equation before you can move on. The equation must be balanced. You can actually check the lesson where I've discussed on balancing of chemical equation. Now let's proceed. Now, if 40 cm cube of hydrogen were exploded with 50 cm cube of air, now assuming air contains 80% nitrogen, so we have to know the amount of nitrogen, then we have to know the amount of oxygen in that air. But don't forget that nitrogen is not reacting, only oxygen is reacting in air. Okay, let us move in this direction. Volume of nitrogen will be 80% means 80 over what? 100 multiplied by the volume of air we have here, which is 50. So we have 40, that is 40 centimeter cube of nitrogen. Okay, volume of oxygen. That will now be 20 over 100 times 50 centimeter cube of air. So we have 10 cm cube of oxygen. Now, initially when hydrogen was exploding in initial volume, we have 2 volume here and we have 1 volume here. Now 2 volume. So initially 2 centimeter, so this is 2 volume means 2 centimeter cube, 1 centimeter cube, and what? 2 centimeter cube. But when hydrogen was reacting with oxygen, water has not been produced in that case. Now, if 40 cm cube of hydrogen is 40 cm cube here, then oxygen that is going to be reacting is going to be 10 cm cube. Initially, this one is not producing. That's initial volume. Initial volume. Nothing is produced. Now, at final volume now, we now look at it. Okay, which of these 40 centimeter cube, which is hydrogen and oxygen, is going to be used up? And which of them will be in excess? Okay, let me assume that hydrogen will be in excess. Let me now calculate the volume of oxygen. So if I now say that 2 centimeter cube, 1 centimeter cube of oxygen is giving 10 centimeter cube. Let me do it that way. Now, let me assume that oxygen is 10 centimeter cube. Let me assume it is used up in the chemical reaction. Then I will now have that 2 centimeter cube, 2 centimeter cube of hydrogen exploded with 1 centimeter cube of oxygen. Now, how many centimeter cube of hydrogen will produce 10 centimeter cube of oxygen? From here, x times 1, we have x equals to 2 times 10, we have 20 cm cube of oxygen. You can see that normally 20 cm cube of oxygen supposed to react here, but 10 centimeter cube was reacting, meaning that this oxygen has been used up. So it's called a limiting reagent. It's called a limiting reagent. So this hydrogen is going to be our excess reagent, which means that this hydrogen will be our excess reagent. Excess by what? By 20 centimeter cube. So from here, if 1 centimeter of hydrogen is giving us 10 centimeter cube, definitely 2 centimeter cube of hydrogen is supposed to give us what? 2 times 10, which is what? 20 centimeter cube. So our hydrogen is in excess. By how much? By this 20 centimeter cube. So this oxygen was used up because normally 10 centimeter cube is supposed to be used to react, but instead we are getting 20 centimeter cube, which means that all this one has been used up while hydrogen will be in excess. By how much? By 20 centimeter cube. So you can now see final volume. Final volume, this one will be 20 centimeter cube, while this one will be 10 centimeter cube, everything reacting. Now, since 2 centimeter cube of hydrogen is producing 20 cm cube, so 2 centimeter cube of water will also produce 20 cm cube. Now, the next thing to now do is to now calculate. Calculate the composition of the resulting gases. Resulting gases are our excess gases or residual gases, the gas left after the reaction. Now, from here, you can see that from here, 40 minus 20, we are going to have 20. 10 minus 10, this one is being used up. Then we have 20 XX here. There's no volume initially, but we have final volume to be 20. So resulting gases. Our resulting gases are hydrogen, water vapor, and nitrogen. Don't forget that nitrogen do not react. It's going to be in excess. So in that case, the volume of nitrogen here is 40 centimeter cube. So we add them together to give us what? 80 centimeter cube. Let's look at this question 3. But before we move on, if you have not subscribed to my channel, kindly do so. And also share and like these lessons. Now, 50 cm cube of a mixture of methane and hydrogen, that is a mixture of methane and hydrogen together, their volume is 50 centimeter cube. were mixed with excess of oxygen and exploded. The products, after cooling to the original room temperature, were treated with excess potassium hydroxide. Excess potassium hydroxide solution when the volume decreased by 40 centimeter cube. Calculate the composition of the original mixture. Want to calculate the composition of the original mixture. Original mixture of methane and the mixture of hydrogen. Want to know the composition. But when we look at this very well, methane is going to explode separately with oxygen. Likewise, hydrogen will explode separately with what? With hydrogen. Here we have, now methane reacts or exploded with oxygen to give carbon dioxide and water vapor. Likewise, hydrogen is going to explode with oxygen to give water vapor separately in this case. Now, when we now look at this, they told us that the products after cooling to the original room temperature were treated with excess potassium hydroxide. The function of this potassium hydroxide is to absorb the carbon dioxide produced. And the carbon dioxide produced has a volume of what? 40 centimeter cube. So from this, let's call this equation 1. Equation 1 and equation 2. From this equation 1, we're going to move on with our calculation. Why? Because information was given about carbon dioxide. So from this carbon dioxide, we can get what we need. That is, methane exploded with oxygen to give carbon dioxide. Now initially we have 1 volume of this, 2 volume of this, and 1 volume of this. So since carbon dioxide was produced from this methane, 1 volume of this gives 1 volume of this. So which means 1 centimeter cube of methane will also produce 1 centimeter cube of carbon dioxide. And carbon dioxide here, we have 40 centimeter cube of carbon dioxide was absorbed from this. So 40 centimeter cube. So when this one now is 40 centimeter cube, this will also be 40 centimeter cube. Fine. So which means that the volume of methane that originally reacted was 40 centimeter cube. Now, but 50 cm cube of a mixture of methane and hydrogen were mixed. So which means that out of this 50, you take away 40 from 50. The remaining one is the volume of hydrogen. So the volume of this hydrogen here, volume of hydrogen will now be 50 cm cube minus 40 cm cube, which give 10 centimeter cube. In this case, the original mixture are 40 cm cube of methane and 10 cm cube of hydrogen. So this is how to go about this. So let's look at another example. Example 4. A mixture consists of 70% methane and 30% of ethane, C2H6. So these are hydrocarbons by volume. Assuming that air contains 20% oxygen by volume, calculate the volume of air needed for the complete combustion of 50 dm cube of the original mixture. Don't forget that I said the constituent of air that is taking part in combustion is that oxygen. Now, we now want to look at the volume of oxygen needed for complete combustion of methane and ethane. So when they mention calculate the volume of air needed, it means that oxygen needed for that complete combustion. And don't forget that we are given the 50 dm cube of the original mixture. So what is the volume of methane? We have to calculate it out. Volume of methane will give us 70 over 100 multiplied by 50 decimeter cube. So I think this is 35 decimeter cube. Also, volume of ethane. That one also is 30 over 100 multiplied by 50 decimeter cube. That one is 15 decimeter cube. So that's the volume of methane and volume of ethane. And methane will combust in that oxygen, while ethane will also combust in oxygen. So these are the equations. Methane will combust in oxygen to give carbon dioxide and water. Likewise, ethane will combust in oxygen to give carbon dioxide and water. Now, from here now, what I want to do is to find the volume of oxygen that will combust in this place. So from here, we can see that this is 1 centimeter cube here, and this one is 2 centimeter cube. This is 2 centimeter cube of ethane. This is 7 centimeter cube of oxygen. So 1 centimeter cube, okay, let me put this in dm cube direct. 1 dm cube, 1 dm cube, 2 dm cube, 2 dm cube. So 1 dm cube, 1 dm cube of methane combusts with 2 dm cube of oxygen. Now, this methane, the volume given here is 35 dm cube of methane will now give how many dm cube of oxygen? X times 1, we have X equals to 35 times 2. So we have 70 decimeter cube of what? Oxygen. That is when methane was exploded. Now, for this ethane, 2 dm cube of oxygen, 2 dm cube of ethane, C2H6, exploded with 7 dm cube of oxygen, 7 dm cube of oxygen. Now, for this ethane here, we got 15 dm cube. So 15 dm cube of ethane will now give us, let's say, y. 2 times y, 2y equals to 15 multiplied by 7. So our y equals to 15 multiplied by 7 divided by 2. So what do we have? 52.5 decimeter cube. Now, what we need is to calculate the volume of air needed for the complete combustion of 50 dm cube of the original mixture. So the mixture are methane and what? And ethane. So the volume of original mixture are, the volume of the original mixture, which are methane and ethane, are 70 dm cube plus 52.5 dm cube to give 122.5 decimeter cube. So which means that this is the total volume of the mixture of methane and what? Ethane. So here we come to the end of the calculations involving Gay-Lussac's law and Avogadro's law. In this case, you can lay your hands on these activities and send it to the number on the screen. Then we'll look at it if you get it right or not, and we'll solve the correction. I remain Latif Ismail Akombi, your mathematics and chemistry tutor. Don't forget to share, like, and leave a comment. Thank you very much.